For centuries, we've been told that our ancestors believed the world was flat, a tale of ignorance, fear, and the edge of the map. But what if that story is a myth? What if the real history is far more fascinating and more surprising? This is the journey of how humanity discovered the true shape and size of our planet, a story of brilliant minds, bold experiments, and the enduring power of evidence. And we'll ask, why, despite all we know, does the flat Earth myth still capture imaginations today? Join us as we uncover the real story of our spherical world and the myths that refuse to die. Our journey begins in ancient Egypt, a civilization born along the banks of the Nile River. The Egyptians were brilliant observers of the sky. Their entire calendar, their agriculture, their religion, it was all tied to celestial movements, like the sun, the star Sirius. They built monumental structures with astronomical alignments. But what did they think about the shape of the world beneath their feet? Most evidence suggests they envisioned a flat land personified by the earth god Geb, with the sky goddess Nut arching over him like a star-covered canopy. This fits a civilization centered on the predictable, flat floodplain of the Nile. Their world was a narrow line of life surrounded by desert. Still, cosmic clues existed. The Egyptians were meticulous record keepers, and they would have noticed things that didn't fit a simple flat model. They saw that the sun's position and the length of shadows changed as one traveled north or south along the Nile. They were also seafaring and trading people, part of a wider Mediterranean world. Their sailors likely witnessed the sinking ship phenomenon. A vessel sailing away doesn't just get smaller and smaller until it vanishes. Instead, its hull disappears first, followed by its mast, as if it's sinking behind a hill of water. By the 3rd century BC, the intellectual world was buzzing with a revolutionary concept. Greek philosophers like Aristotle had already presented compelling arguments for a spherical Earth, observing the planet's curved shadow on the moon during an eclipse, and how ships disappeared hull first over the horizon. The idea of a round Earth was now in the air, but it was still just an idea, a philosophical truth without a physical measure. It was a world without a scale. The epicenter of this intellectual ferment was the Great Library of Alexandria in Egypt. And at its head was a man of formidable intellect, a true polymath named Eratosthenes. He was a geographer, a mathematician, an astronomer, a poet, and a historian. His contemporaries nicknamed him Beta because he was supposedly the second best in every field. But in this one instance, he would prove to be second to none. As the keeper of the world's accumulated knowledge, Eratosthenes was a person who read everything. Surrounded by hundreds of thousands of papyrus scrolls, he sifted through reports from across the known world. And one day, buried in a seemingly mundane text, he found a fascinating report from the southern outpost of Syene, a city located near modern-day Aswan. The report described a peculiar and striking phenomenon. It noted that in Syene, on the longest day of the year, the summer solstice, at precisely noon, the sun's rays shone straight down a deep well, illuminating the water at the very bottom. This meant the sun was directly, perfectly overhead. A vertical column or stick would cast no shadow at all. Eratosthenes, living in Alexandria, knew this wasn't true where he was. Even on the solstice, a stick in the ground in Alexandria cast a distinct shadow. Why would the sun be directly overhead in one city, but at a slight angle in another, at the very same moment? For most, this might have been a forgettable curiosity. For Eratosthenes, it was the key to unlocking the size of the entire planet. An idea sparked in his mind, an idea of such breathtaking simplicity and genius that it stands as one of the most brilliant in the history of science. He reasoned that the sun is so far away, its rays arrive at Earth essentially parallel to one another. If the Earth were a flat plane, then those parallel rays would strike the ground at the same angle everywhere. A vertical stick in Siena and a vertical stick in Alexandria would cast identical shadows. But they didn't. The fact that there was no shadow in Siena, but a measurable shadow in Alexandria, could mean only one thing: The surface of the Earth between the two cities was curved. And here was the masterstroke. Eratosthenes realized that the angle of the shadow cast by his stick in Alexandria must be the same as the angle separating Alexandria and Syene from the very center of the Earth. With this insight, a simple shadow became a tool to measure the world. He realized he could use this angle and the distance between the cities to calculate the Earth's entire circumference. So, on the next summer solstice, he set up his experiment. It was an experiment elegant in its profound simplicity. As noon approached in Alexandria, he carefully measured the angle formed by the top of the gnomon and the tip of its shadow. He found it to be about 7.2 degrees. Now came the calculation. A full circle, the entire circumference of the Earth, is 360 degrees. The angle he measured, 7.2 degrees, is exactly 1/50th of that circle. This meant the distance between Alexandria and Syene must be 1/50th of the Earth's total circumference. All he needed now was that distance. Eratosthenes didn't have satellite mapping, of course. Instead, he relied on the records of bematists, professional surveyors trained by the army to walk in precise, even steps to measure roads. They had paced out the distance between the two cities as approximately 5,000 stadia. The final step was simple arithmetic. 5,000 stadia multiplied by 50. The result, 250,000 stadia. This was his calculation for the circumference of the entire world. While there's some debate over the exact length of the ancient stadium, his measurement was astonishingly accurate, likely within just a few percent of the value we know today. With a stick, a shadow, and the power of human reason, Eratosthenes had not just confirmed the world was round, he had grasped its true, immense scale for the very first time. After the fall of the Roman Empire, a common misconception is that Europe plunged into 1,000 years of intellectual darkness. We call this period the Dark Ages. That name implies science was forgotten and everyone believed the Earth was flat. The story says the Church suppressed Greek knowledge and enforced a biblical flat Earth cosmology. It's a dramatic tale, but it's a myth. Knowledge of a spherical Earth was never truly lost. It was preserved. It was copied. It was taught. St. Augustine, St. Jerome. Both knew the Greek model of a spherical Earth and discussed it in their writings. Their primary concern was theology, not geography. They focused on salvation of the soul rather than the planet's shape. So the Earth's shape was treated as a minor detail. A few obscure writers argued for a flat Earth from literal scripture, but they were exceptions. The mainstream tradition carried the sphere forward. Isidore of Seville, 7th century scholar, he wrote the Etymologies, a massive encyclopedia. It became widely read, widely copied, a standard textbook for centuries. In it, Isidore described the Earth as a globe. Later, Bede wrote about a spherical Earth and used it to explain seasonal daylight. Now we arrive at one of the central figures in the flat Earth myth, Christopher Columbus. The popular schoolchild story tells of a lone visionary, a man of singular genius who believed the Earth was round while the supposedly ignorant kings and scholars of his day insisted it was flat. In this heroic tale, he had to fight against widespread superstition and fears of sailing off the edge of the world. He then proved them all wrong by simply not falling off. The only problem is, this compelling narrative is almost entirely false. The reality of the situation in the late 15th century was far more nuanced and scientifically grounded. The debate was never about whether Earth was round. That fact was settled science. By 1492, every educated person, including Queen Isabella's scholars and King Ferdinand, knew it was a sphere. This knowledge wasn't new or controversial. It was foundational. The ancient Greeks had proved it centuries earlier through simple, elegant observations, like the curved shadow the Earth casts on the moon during a lunar eclipse, or how ships disappear hull first over the horizon. The medieval universities taught it as standard curriculum. No, The real debate, the one that truly mattered, was about the Earth's size. And on this crucial point, Columbus was spectacularly, dangerously wrong in his calculations. The Spanish experts, the very scholars who advised the crown, trusted the work of ancient masters like Eratosthenes and Ptolemy. Their calculations, passed down through centuries, were remarkably accurate. The commission at Salamanca, appointed to review Columbus's proposal, wasn't a council of flat earthers. They were learned men who checked his math and found it wanting. They knew the westward distance to Asia was immense, far too far for the ships of the day to survive. Based on the accepted circumference of the globe, they correctly calculated that a crew would run out of food and water long before reaching the Orient. To make his voyage seem feasible, Columbus cherry-picked data to drastically shrink the world. He made two critical, self-serving errors. First, he accepted a much smaller circumference for the Earth. He dismissed Eratosthenes' accurate figures in favor of less reliable sources and may have even misinterpreted the units of measurement, confusing longer Arabic miles with shorter Roman ones. This alone shrunk the planet in his proposal by about 25%. Second, he vastly overestimated Asia's eastward extent, relying on the exaggerated accounts of Marco Polo. He believed Japan was thousands of miles closer to Europe than it actually is. By combining these two massive errors, he essentially shrunk the ocean in his mind to a manageable, sailable size. So he wasn't arguing round versus flat, but small versus large. The scholars who advised against him were not ignorant. They were the real scientists of their day. Their warnings were logical, based on the best available evidence. They understood the true scale of the planet. Columbus, driven by ambition, was the one engaging in wishful thinking. If the Americas hadn't been there, blocking his path, his crew would have perished, starving in the middle of a vast empty ocean. The experts tragically proven right. The widespread belief that our ancestors, particularly in the Middle Ages, were convinced the Earth was flat is a powerful image. We picture them huddled in fear, believing ships could sail right off the world's edge. But this entire picture of a historical flat Earth consensus is largely a 19th century invention. It began not with a historian, but with a storyteller. Washington Irving's 1828 biography of Christopher Columbus was a bestseller, but it was also romanticized and largely fictional. To create drama, he invented vivid scenes of Columbus, the lone, rational hero, arguing against a council of foolish, dogmatic churchmen. These characters, armed with misquoted scripture, supposedly insisted the world was a flat plane. Irving was a master of historical fiction, and his audience, captivated by the narrative, accepted the drama as fact. The compelling image of the brave explorer versus the ignorant clergy stuck, planting a seed that would soon grow into a foundational myth. That seed was later supercharged by two influential academics, John William Draper and Andrew Dickson White. In the late 19th century, they championed what became known as the conflict thesis. In books like History of the Conflict Between Religion and Science, they argued that history was a continuous war between scientific progress and religious dogma. The flat Earth story became their prime exhibit. They painted the entire Middle Ages as a 1,000-year period of faith-based ignorance and intellectual suppression, a dark age from which science had to be rescued. Their goal was explicitly political: to discredit the influence of religion in their own era's universities and public life. Modern historians have thoroughly debunked this. The relationship between faith and science was never a simple war. It was complex and often collaborative, with the church acting as a major patron of learning for centuries. But the fictional story was just too good to let go. It was simple, dramatic, and easy to remember. It seeped into textbooks and popular culture, repeated so often it became an unquestioned fact. Which brings us to the profound irony of our time. We live in an age where we can see the gentle curve of our planet from space stations orbiting above. We have a constant stream of satellite imagery confirming our world is a sphere. And yet the belief in a flat Earth, a myth born from a 19th century fiction, is not only persisting, it's growing. Why? Because the myth survives by appealing to deep-seated psychological needs. It's simple and satisfying. It also flatters our modern ego, a phenomenon known as chronological snobbery, the arrogant assumption that we are inherently smarter than our ancestors. The messy truth is that ancient people were brilliant observers, and medieval scholars diligently preserved and studied the very classical knowledge that confirmed a spherical Earth. The relationship between science and faith was complex and intertwined, but myths are often more emotionally resonant than nuance. In our digital age, a general distrust of authority and a powerful search for belonging amplify these beliefs, creating online communities where the flat Earth narrative is not just a theory, but an identity. Ultimately, the endurance of this myth is a powerful lesson in critical thinking. Always question the simple, satisfying stories, especially the ones that make you feel superior.